Hi students, welcome back to Inview Point. So today I'll be taking a second demo class on class 10th science subject, chemical equations and reactions. I hope you have seen our first demo class on motion, class 9th science subject. If you haven't seen it, I am giving the link in the description box. Please do watch and subscribe our channel. So let's begin this class. So students, today we'll be discussing what is a chemical reaction, what is a chemical equation, what is balanced and unbalanced chemical equation, how to write a balanced chemical equations, and what are the different types of chemical reactions. And we'll be discussing about combination reaction, one type of chemical reaction in detail. Okay. So students, let's begin the class. See, you may have observed that milk turns sour when left outside, right, in the summer. That is, fermentation of milk occurs, right? Similarly, you may have seen rusting of iron, that is, a brown dust around the iron nails or iron chains, right? These are all examples of chemical reaction in our daily life. Okay. When you eat food, the complex food gets digested in our stomach and is converted to its simpler form, glucose. So digestion is an example for chemical reaction. Similarly, respiration is an example for chemical reaction, and burning of wood, that is also an example for chemical reaction. So from these all, what do you understand? Whenever a chemical change occurs, a chemical reaction takes place. So what is a chemical reaction, students? A chemical reaction involves a chemical change, okay, in which substances react to form new substances with entirely new properties. Okay, do you understand that? We'll be discussing about in detail. So what is the definition for a chemical reaction? A chemical reaction involves a chemical change in which substances react to form new substances with entirely new properties. Is that clear, students? So let's discuss about chemical reaction in detail. Okay. Okay, students. Now let's discuss an example for chemical reaction. Okay. Take a magnesium ribbon and burn it using a burner or a spirit lamp. Okay, so when you burn it, the magnesium ribbon will turn into ash, right? So collect that ash in a watch glass. Okay, then what do you observe? You observe that this magnesium reacts with oxygen in the air. Okay, when you burning means it requires oxygen. Okay, so magnesium reacts with oxygen in the air to form a white powdered ash. And what is this white powdered ash? It is magnesium oxide. Okay, so we find that magnesium reacts with oxygen to form magnesium oxide. Is that clear, students? So this is an example for chemical reaction. Okay, then let's discuss another example. Take a test tube or a conical flask, okay, and put some zinc granules in the test tube. Okay, here they have taken a test tube. Okay, in the figure it is a test tube. Put some zinc granules in it. Then add dilute sulfuric acid or dilute hydrochloric acid to these zinc granules. Okay, then what do you observe? There are two observations. Okay, one is you can see gas evolving from this test tube. Okay, what is this gas produced? It is hydrogen gas. How do you know it is hydrogen gas? Suppose you are passing this gas through a soap solution. Okay, then bubbles are formed, right? Soap bubbles are formed with the hydrogen gas. Okay, take a candle, light it, and place the burning candle near the soap bubble filled with hydrogen. Then what do you see? The candle will burn with a pop sound. Okay, is it clear, students? This indicates the presence of hydrogen gas. Okay, so students, listen to this properly because this observation has been asked in your previous questions. Okay, they have given this. They said they have given this activity and they have asked what is a chemical reaction. Write the chemical equation and how and give the um, test for hydrogen gas. Okay, so how do you test it with the gas formed as hydrogen gas? Suppose you are passing this hydrogen gas through a soap solution. Soap bubbles are formed filled with hydrogen gas. Okay. Place a burning candle near this soap bubble. Then the candle will burn with a pop sound. This indicates the presence of hydrogen gas. Is it clear, students? Okay. So one observation is hydrogen gas evolves, right? Another observation is that if you touch the test tube, then you may feel it hot. That is, there is a rise in temperature. Okay, so these are the two observations when zinc granules react with dilute sulfuric acid or dilute hydrochloric acid. Okay, is that clear, students? Okay, this is an example for chemical reaction. Okay, another example is take some lead nitrate solution in a test tube. Okay, and pour some potassium iodide to this lead nitrate. Then what do you observe? As you pour the potassium iodide to lead nitrate solution, a yellow precipitate is formed. Okay. So what is this yellow precipitate? It is lead iodide. Is it clear, students? So when you pour potassium iodide solution to lead nitrate solution, a yellow precipitate is formed. That is lead iodide. Okay. Okay. So this is an example for chemical reaction. So from all these activities, what do you observe? You can say that whenever there is a change in state, okay, or there is a change in color, or evolution of gas occurs, or there is a change in temperature, then we can say a chemical reaction has taken place. Okay, is that clear, students? So first we studied that whenever a chemical change occurs, we can say that chemical reaction takes place. Now from all these above three examples, we can say that whenever there is a change in state or change in color or evolution of gas occurs or change in temperature, then a chemical reaction has taken place. Okay, you may find one or more of these observations whenever a chemical reaction takes place. Is that clear, students? Okay. Now let's discuss what is a chemical equation. Okay, so students, what is a chemical reaction? A chemical reaction involves a chemical change in which substances react to form new substances with entirely new properties, right? So a chemical equation. So we studied what is a chemical reaction. Now we'll be studying what is a chemical equation. Okay, a chemical equation is representation of chemical reaction using symbols and formulae of the substances. Okay, so what is a chemical equation? Representation of chemical reaction using symbols and formulae of the substances is called a chemical equation. Okay. Suppose two substances A and B react together to form C and D. Okay. Then we can say that here A and B are the reactants. Okay. And C and D are the products. Okay. So what is a reactant? The substances which react, okay, in a chemical equation, that is called reactants. Okay, so here A and B are the reactants while the products formed are C and D. Okay, and the arrow indicates the direction of the reaction. Okay, so here the reactants are always written on the left hand side of the arrow and products are written on the right hand side of the arrow. Okay, the arrow indicates the direction of reaction. Is that clear, students? So a chemical equation is a representation of chemical reaction using symbols and formula of the substances. Okay, reactants are the substances which react. Okay, so here A and B are the two substances which react together to form C and D. So A and B are the reactants while C and D are the products. And reactants always are is always written on the left hand side, and products are written on the right hand side of the arrow. The arrow indicates the direction of the reaction. Okay. So now let's write the chemical equation for the activity burning of a magnesium ribbon. See here, what was the chemical reaction? Magnesium reacts with oxygen to form magnesium oxide. Okay. So how do you write the equation in word in a sentence? We can write as magnesium plus oxygen gives magnesium oxide, right? So here the reactants are magnesium and oxygen, right? Magnesium and oxygen reacts together, right? So magnesium and oxygen are the reactants, while what is the product? These two react to form magnesium oxide. So that is the product. Okay. So what is the chemical equation actually? It is a representation of chemical reaction in using symbols and formula of the substance, right? So what is write this symbol? What write the formula of the substance? How do you what is the formula of magnesium? It is Mg. And what is the formula of oxygen? O2. And MgO is the formula for magnesium oxide. So what is the chemical equation here? It is Mg plus O2 gives MgO. Okay, is that clear, students? So here magnesium and oxygen reacts together to form magnesium oxide. So magnesium and oxygen are the reactants, while magnesium oxide is the product. There is only one product, that is magnesium oxide. Write the symbol formula for the each substance, then you will get the chemical equation, that is Mg plus O2 gives MgO. Is that clear, students? MgO, magnesium oxide, is a white powdered ash obtained here. Okay. Okay. Take the second activity. When zinc granules are taken in a conical flask. Here see a conical flask is shown, and you're adding dilute sulfuric acid to this zinc granules. Okay. Then one observation was hydrogen gas evolves, right? So here when zinc reacts with dilute sulfuric acid, one product is formed as hydrogen. Then what is left? The zinc will react with sulfur SO4 in the dilute sulfuric acid to form zinc sulfate. So there are two products. Okay, so what is the chemical reaction? How do you write it in a sentence? We can write zinc will react with sulfuric acid to form zinc sulfate and hydrogen. Here there are two products. So what are the products here? Zinc sulfate and hydrogen. The reactants are zinc and sulfuric acid. Okay. So now write this formula for the equation. What is the formula? Zinc is represented as Zn. Zn is the symbol. Okay. Sulfuric acid formula is, chemical formula for sulfuric acid is H2SO4. Okay. Zinc sulfate, the chemical formula is ZnSO4. Then hydrogen is left. Hydrogen is represented as H2. Okay, is that clear, students? So this is the chemical equation for the reaction, given chemical reaction. Okay. Okay. Now, then write the chemical reaction, chemical equation for this reaction. Lead nitrate reacts with potassium iodide to form what? I told you, the yellow precipitate is lead iodide, right? So lead, here in this lead nitrate, lead is there. In the potassium iodide, lead iodide is there. So lead and iodide is one product. Lead iodide is one product. So what will be the other product? It will be, what is remaining? Potassium, and here nitrate, right? So another product is potassium nitrate. Okay, is that clear, students? So here the lead nitrate will react with potassium iodide to form what? Potassium nitrate plus lead iodide. Okay. So here the reactants are lead nitrate and potassium iodide, and the products are potassium nitrate and lead iodide. This yellow precipitate is our lead iodide. Okay. Then write the formula for this. Then only you will get the chemical equation, right? So the lead nitrate chemical formula is PbNO3 twice. Okay, and potassium iodide is represented as Ki. Okay, and potassium nitrate, the chemical formula is KNO3, and the chemical formula for lead iodide is PbI2. So what is the chemical equation? PbNO3 twice plus Ki gives KNO3 plus PbI2. Is that clear, students? So this is the chemical equation for the chemical reaction. See, students, you may be new to the chemical formula. Okay, you may not be knowing all the chemical formulas. Only through practice, doing solving so many questions, you will come to know the exact formula. Okay, it is important that you know the formula, because then only you will be able to solve a chemical equation. No, you'll be able to solve a balanced chemical equation. Okay, we'll be studying about that in detail. So practice more and more questions. Okay, then you'll be able to write a proper chemical equation. Okay, then now let's discuss balanced and unbalanced equation. Okay, so before you study what is a balanced and unbalanced equation, you may have to you may have studied what is law of conservation of mass in your earlier class, right? So let's just revise it. Okay, so what is law of conservation of mass? Law of conservation of mass states that mass can neither be created nor destroyed in a chemical equation, right? So law of conservation of mass states that mass can neither be created nor destroyed, right? So when we are applying that to this chemical equation, what can we say? We can say that the total mass of elements present in the products of a chemical reaction should be equal to total mass of elements present in reactants. Okay, so we can say that total mass of elements present in products of a chemical reaction is equal to total mass of elements present in reactants. Or we can say that the number of atoms of each element remains the same before and after a chemical reaction. Is that clear, students? So, by the law of conservation of mass, we can say that the number of atoms of each element remains the same. Okay, it is equal before and after a chemical reaction. Okay. Okay. So let's study what is a balanced chemical equation. Okay. Balanced chemical equations are those chemical equations having equal number of atoms for each element in the reactants and products. Okay. So, balanced chemical equations are those chemical equations having equal number of atoms for each element in the reactants and products. Okay, let's discuss about it through an example. See here, you have studied this reaction, right? We saw it before. Zn plus H2SO4 gives ZnSO4 plus H2, right? Zinc reacts with sulfuric acid and forms zinc sulfate and hydrogen gas, right? See here in the reactant side, first let's identify the elements present in the equation. Okay, so what all elements are present here? One element is zinc, right? Another is hydrogen, another is sulfur, another element is oxygen, right? So these are the four elements present in this chemical equation. Okay, now let's find the number of atoms of each element in the reactant and product side. Okay, let's take the first element, zinc. Okay, so how many atoms of zinc are there in the reactant side? That is Zn, right? So there is only one atom, one zinc atom in the reactant side. Okay, then in ZnSO4, that is in the product side, how many zinc atoms are there? It is again Zn, right? So the number of atoms will be 1. So we can say that there is one atom each of zinc element in the reactant as well as product side, right? Now take another element. The other element is hydrogen. Okay, if you're taking hydrogen, how many atoms are there in the reactant side? It is H2, right? In the H2SO4, it is H2. So there are two hydrogen atoms in the reactant side, and here also it is H2. So there are two hydrogen atoms in the product side. So the number of hydrogen atoms in the reactant as well as the product side is equal. Okay. Now, if you take sulfur, you can see the number of atoms, sulfur atoms in the reactant side is 1. It is S, right? So it is 1, and here also it is in the product side, it is 1 itself. So the number of sulfur atoms in the reactant and product side are equal. Okay. How many oxygen atoms are there in the reactant side? There are 4 oxygen atoms in the reactant side because it is O4, right? Is it clear, students? So there are 4 atoms, oxygen atoms in the reactant side, and here also it is O4 in the product side. So there are 4 oxygen atoms in the product side. So we can say that, see, for each element, the number of atoms in the reactant and product side are equal, right? So we can say that the chemical equation is balanced. Okay, is that clear? Now let's see another equation. Okay, see, the lead nitrate and potassium iodide gives potassium nitrate and lead iodide. This is the chemical equation. Okay, let's see what all are the elements here. It is, one is lead, Pb. Okay, is lead. Okay, then another element is nitrogen, another element is oxygen, then other two elements are potassium and iodide. Okay, now let's find the number of atoms of this element, of each element in the product and reactant side. Okay, I'm explaining this example also so that you can understand clearly the concept. Okay, so let's take the first element, lead. How many lead atoms are there in the reactant side? See, it is PbNO3 twice. So there is only one lead atom, right? Pb. So there is only one lead atom in the reactant side, and here also it is PbI2. So there is only one atom in the product side. Is it clear, students? So see, we can see the number of atoms of lead in the reactant side and product side is equal. Okay, we have to see that the number of atoms for all the elements should be equal in the reactant as well as product side. Then only the chemical equation is balanced. Okay, so let's take another element. See, nitrogen. Okay, so here it is, nitrogen is present as in which form? NO3 twice. Okay, so NO3 is a molecule, and it is given, it is, there are two NO3 molecule. So it is NO3 twice. So here you can say it is, here it is 1. We don't write 1 as such. Okay, so it is, number of nitrogen atoms is how much? 1 into 2. That is how much? 2. So there are 2 nitrogen atoms in the reactant side, and here in the product side, here you can see it is N, right? It is N alone. So there are, it is N alone, but see here it is written 2KNO3. That means you should multiply. There are 2 nitrogen atoms here. So here also there are 2 nitrogen atoms in the product side. So we can see that the number of nitrogen atoms in the reactant side as well as in the product side are equal. Okay, is that clear? Okay, you'll be more clear when we discuss about the number of atoms of oxygen atoms in the reactant side and product side. Okay, so consider oxygen molecule. Okay, oxygen element. Then how many atoms are there here? See, it is O3 twice. So the number of oxygen atoms is 3 into 2. That is how much? 6. So the number of oxygen atoms is 6 here. Okay. Then here in the product side, you can see it is O3. Okay, KNO3. But it is 2 times KNO3. So multiply this 2 with 3. Then you'll get how many oxygen atoms? It is 6. Okay. So the number of oxygen atoms in the reactant side and product side are equal. Okay. Then what are the remaining elements? It is potassium and iodide. Similarly, find the number of atoms of potassium and iodide in the reactant and product side. See here it is 2Ki, 2Ki, right? So the number of potassium element is how much? 2 in the reactant side, right? And in the product side also it is 2 times KNO3, so 2K. So the number of potassium elements is how much? 2 itself. So see it is equal, right? So it is 2 in there are 2 potassium atoms each in the reactant side as well as in the product side. Okay. So for iodide it is again 2I, right? So the number of atoms is iodine atoms are 2, and here also it is in the product side it is I2. So the number of iodine atoms in the product side is 2. Okay. So we can see that for all the elements, the number of atoms in the reactant side as well as product side is equal. So such a chemical equation is known as a balanced chemical equation. Is that clear, students? Okay. So what is an unbalanced chemical equation? Unbalanced chemical, this is another example for balanced chemical equation. Check it yourself, okay, whether it is balanced or not. Okay, Ag is silver. This is so silver iodide plus sodium sulfide gives silver sulfide plus 2 sodium iodide. Okay, so what is an unbalanced or skeletal chemical equation? Unbalanced chemical equations are those chemical equations having unequal number of atoms for each element in the reactants and products. Okay, so if the number of atoms of any element in the reactant or product side is not equal, then such chemical equations are known as unbalanced chemical equation, or you can say them as skeletal form of chemical equation. Okay, so it is a skeletal form of chemical equation. Okay, is that clear, students? Okay, so let's take an example and discuss. Okay, see here the elements are calcium, chlorine, sodium, potassium, and oxygen. Okay, so here in the reactant side, the number of calcium atoms is 1, but here in the potassium, in the product side, the number of calcium atoms is how much? It is Ca3, right? So there are 3 calcium atoms in the product side. So for one element itself, it is not equal, right? The number of atoms for the element in reactant side and product side is not equal. Okay, so we can say this is an unbalanced chemical equation. See, let's check it for another element. Take phosphor. Okay, see here then it is Na2PO4. So P, right? So the number of phosphor atoms in the reactant side is 1. Here in the product side it is PO4 twice, right? So multiply this. Here it is 1, right? So multiply this 1 into 2, that is P2, right? So the number of oxygen phosphor atoms is 2 here. So that is also not equal. So the number of phosphor atoms is also unequal in the reactant and product side. So we can say the equation is unbalanced. Now, okay, so check it for another chemical equation, okay, whether it is balanced or unbalanced, okay. Try it yourself, okay. Now, if you are given an unbalanced chemical equation, how will you make it as a balanced chemical equation? Okay, this is an important topic. This question has been asked several times in your question papers for the board exam. So please pay attention. Okay, so now let's see how to write a balanced chemical equation. Suppose the given chemical equation is Fe plus H2O gives Fe3O4 plus H2. So the reactants here are iron and water, right? Fe is what? Iron. Iron and water is the reactants, and Fe3O4 and H2 is the products. Okay, so this is the chemical equation. What all are the elements here? It is iron, hydrogen, and oxygen, right? So let's see whether the chemical equation is balanced or unbalanced. See here the let's take the first element, iron. Okay, So the number of atoms of iron in the reactant side is what? It is Fe, so it is 1. Okay, so 1 iron atom is present in the reactant side. How many iron atoms are present in the product side? It is Fe3. So 3 iron atoms are present in the product side. So it is not equal, right? In the reactant side and product side, the number of atoms of iron is not equal. So this is an unbalanced chemical equation. So we have to make it as balanced. So what all are the steps to make it as a balanced chemical equation? So let's find it. So the first step is, you see, I told you the reactants are iron and water, right? And the products are Fe3O4 and H2. So first step is put the reactants, each reactant and each product inside a box. Okay. So see here, I am putting, I put the Fe in a box. Now put H2O inside a box. Okay. Put F3O4, Fe3O4 in a box. Then put H2 in a box. Okay. So this is the first step. After putting the box, whatever calculations you are doing, never write it inside the box. Okay. Okay. So once you put the elements inside the box, do not touch it. Okay. Once you put the reactants and products inside the box, do not write any calculations inside the box. Is it clear, students? Okay. So the second step is identify each element and find the number of atoms of each element in the reactant side and the product side. Okay. So what all are the elements here? There are three elements, right? Iron, hydrogen, and oxygen, right? So let's find the number of iron. Let's take first iron, okay? Iron element. Find the number of atoms of iron in the reactant side. See, it is Fe, right? So the number of iron atoms in the reactant side is 1, okay? And the number of iron atoms in the product side is how much? It is Fe3. So the number of iron atoms will be 3, right? So see here, you can see that the number of iron atoms in the reactants and product side is different. So we can see that the chemical equation is unbalanced, right? Then now let's take the hydrogen atom. Okay. Find the number of hydrogen atoms in the reactant side. See, it is H2. So there is 2 hydrogen atoms in the reactant side, right? And in the product side, it is again H2. So the number of hydrogen atoms in the product side is how much? 2. Okay. Now find the number of oxygen atoms in the reactant side. It is H2O. So it is O alone. So the number of oxygen atoms is 1 in the reactant side, and in the product side it is O4, right? So there are 4 oxygen atoms in the product side. Okay, so we can see the number of iron atoms and oxygen atoms in the reactant and product side are different. So we can say that the chemical equation is unbalanced. Is it clear, students? So we have to make it as balanced chemical equation. How do we do it? Let's see the next step. Okay, so third step is, for the third step, choose any element. Okay, here mostly we choose a element having the highest number of atoms so that our mathematical calculations are easy. Okay, so see here you can see that oxygen is having the highest number of atoms. So first let's take oxygen. Okay, instead of oxygen you can take iron or hydrogen, it doesn't matter. But here let's take the oxygen atom first. Okay, so find the number of oxygen atoms in the reactant side. See, it is H2O, right? So the number of oxygen atoms in the reactant side is how much? 1. And the number of oxygen atoms in the product side is O4. So 4. Okay. So see, the number of oxygen atoms in the reactant side and product side are different, right? So we have to make it equal. So how do you make it equal? Multiply this 1 with 4, right? So multiply this 1 with 4. If you multiply this 1 with 4, what do you get? Here the number of reactants in number of oxygen atoms in the reactant side will become 4, and number of oxygen atoms in the product side will also become 4, right? Is it understood? So the here the number is equal, right? So what for, in order to make it equal, what we are doing, we are multiplying this 1 with 4, right? That is, here we are multiplying, there is only one oxygen atom, right? In the reactant side, we are multiplying it with 4. So write this 4 outside the box, okay, containing the oxygen atom. So here oxygen atom is present in the H2O molecule, right? So we are multiplying this with 4, okay? So write this value 4 outside the box, okay? So never write any calculations inside the box. Once you put the reactants and products inside the box, never touch it. Is it clear, students? Okay. So now let's take, so the equation becomes what? Fe plus 4H2O gives Fe3O4 plus H2. Okay? Okay. Then, now let's take the another element. Suppose take it as hydrogen. So find the number of hydrogen element atoms in the reactant side and product side. See here it is given as 4H2O. So it is 4 times H2. That is the number of atoms is how much? 4 into 2, that is 8. Okay. And in the product side, the number of hydrogen atoms is, see it is H2. So the number of atoms is 2. Okay. So we have to make it equal. So what do? Multiply this 2 with 4. Right. If you are multiplying this with 4, then the number of hydrogen atoms in the reactant side as well as the product side becomes equal. Okay. Is it clear now? So we are multiplying the 4. Okay, we are multiplying the 2 with 4 in the product side. Okay, so we are multiplying it with 4, and this hydrogen atom is present as H2, right? So write the value 4 outside the box containing hydrogen. Okay, so now the equation becomes what? The equation becomes Fe plus 4H2O gives Fe3O4 plus 4H2. Is that clear, students? Okay. So find the next is, what is the remaining element left? It is iron, right? So take the iron element and find the number of iron atoms in the reactant side and the product side. Okay. So here in the reactant side, the number of iron atoms is 1, and in the product side, here the number of iron atoms is 3, right? It is Fe3. So there are 3 iron atoms. Okay. So make it equal. So in order to make it equal, multiply this 1 with 3. Okay. So the number of iron atoms in the reactant side becomes 3, and number of iron atoms in the product side becomes 3. Okay. So now the iron atoms in the reactant side and product side is equal, right? See, we are multiplying the value 3 in the reactant side. So what we do? See, iron is present as Fe, right? So write the value 3 outside the box containing iron atom. So the equation will become 3Fe plus 4H2O gives Fe3O4 plus 4H2. Is that clear, students? Okay, so we have taken all the 3 elements and we have made it equal, right? The number of atoms in the reaction side and product side is equal. So let's check it. The next step is take all these elements down and find the number of atoms of each element in the reactant side and product side for the revised chemical equation. Okay, so in the last step we got the chemical equation as 3Fe plus 4H2O gives Fe3O4 plus 4H2, right? So first let's take the iron element. So find the number of iron atoms in the reactant side. It is 3Fe. So the number of atoms will be 3 in the reactant side, and in the product side it is Fe3. So the number of atoms in the product side is also 3. Okay, see now it is equal, right? Then take the next element, hydrogen. See, it is 4H2, right? So the number of hydrogen atoms is 4 into 2, that is 8. Okay. And in the product side, we get 4 into H2, that is also 4H2. So 4 into 2, 8. Okay, so here the number of hydrogen atoms is also same. Okay, then take the oxygen atom. See, it is 4H2O. So 4O. Okay, so the number of oxygen atom in the reactant side is how much? 4. And in the product side, it is O4. See, Fe3O4, right? So O4. So number of oxygen atoms in the product side is 4. So we can see that all elements are having equal number of atoms in the reactant side and the product side. So the equation is balanced, right? So write the equation once again, removing the box. So here this is the balanced chemical equation. That is, it is what 3Fe plus 4H2O gives Fe3O4 plus 4H2. Is it clear, students? Okay. Normally we write in the balanced equation uh, as such. Sometimes we write the balanced equation along with the physical states. Okay. See, iron is a solid, right? So that is S denotes solid. And then H2O. H2O is water. That is the physical state is given as gas. That is, we the water is in steam. Water is in the steam form. Okay. Then Fe3O4 is also a solid, and hydrogen is another a gas. Okay, so is that clear, students? Okay, now let's discuss one more example so that you are thorough with this concept. Okay, so students, sometimes the chemical equation will be given as a statement instead of equation. Okay, so see here, the given chemical reaction is barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. See, so here the reactants are barium chloride and aluminum sulfate. Okay, these two react to form the products what aluminum chloride and barium sulfate. So, what is the chemical equation? It is a representation of the chemical reaction in using symbols and formulae of the substance, right? So write the formula of these reactants and products. So the chemical formula for barium chloride is BaCl2, and Al2SO4 thrice is aluminum sulfate, AlCl3 is aluminum chloride, BaSO4 is barium sulfate. Okay, so these two are the reactants and these two are the products. Okay. So we have to make this as a balanced chemical equation. So first step is we have to put all these reactants and products inside a box. See, we have put all the reactants and products inside a box. Okay. So what is the second step? We have to identify the elements. So here the elements are barium, chlorine, aluminium, sulfur, and oxygen. Okay, these are the elements present in this chemical equation. So find the number of atoms in reactant side and in product side. Here, let's take barium. Okay, here in reactant side, it is Ba, right? So the number of atoms is 1. And in the product side, it is also Ba. So the number of atoms in product side is also 1. Okay, take consider second element chlorine. The number of atoms of chlorine is how much? In reactant side it is Cl2, right? So the number of chlorine atoms is 2, and here in the product it is Cl3. That is, there are 3 chlorine atoms in the product side. Okay. Then now let's take aluminum element. Okay, in the reactant side it is Al2. So there are 2 aluminum atoms in the reactant side, and in the product side it is Al. So there is 1 atom in the product side. Okay, then next is sulfur, right? See here in the reactant side it is SO4 thrice, right? Inside the bracket it is there is only one sulfur atom, then it is given SO4 thrice. So multiply this 1 with 3. Okay, so you get there are 1 into 3 is how much? 3. So there are 3 sulfur atoms in the reactants, and there is only one sulfur atom in the product. Okay, then find the number of oxygen atoms in the reactant side. Inside the bracket there are, it is O4, right? So there are 4 oxygen atoms here. Then it is given O4 thrice, right? So multiply this 4 with 3, so you'll get 4 into 3 is how much? 12. Okay, and here in the reactant side it is O4. So the number of atoms in the product side is 4. So see students, except barium, all the elements are having unequal atoms in reactant side and product side. Okay, so we can say that this equation is a unbalanced chemical equation. Okay, so what is the third step? Identify the element having maximum number of atoms. Okay, so here oxygen is having the maximum number of atoms. So consider the oxygen element. Okay. So the number of oxygen atoms in the reactant side is how much? It is O4 inside the bracket and outside is written thrice, right? SO4 thrice. So the number of oxygen atoms is 4 into 3, that is how much? 12. Okay. Then in the product side, the number of oxygen atoms is O4. So the number of atoms is 4. Okay, so we have to make it equal to make the equation balanced. So how we will make it equal? Multiply the 4 with 3. Okay, so now in the reactant side the number of oxygen atoms is 12, and in the product side also the number of oxygen atom is 12. Okay, so here we are multiplying the product side with a value 3, right? See here, we are considering oxygen atom. So oxygen atom in the product side is in the form of BaSO4, right? So here, write the value 3, okay, the multiplication factor outside the box containing the oxygen element. Is it clear, students? So here, initial, the value of oxygen was how much? 12 in the reactant side and 4 in the product side, right? So we are multiplying this 4 with a factor 3 so that the number of oxygen atoms in the reactant side and product side are equal, right? So this value 3 is written in the product side, right? We are multiplying with 3 in the product side, right? So here the oxygen is present in this box, right? So we are writing the value 3 outside this box. Okay, so now the chemical equation becomes what? BaCl2 plus Al2SO4 thrice gives AlCl3 plus 3 times BaSO4. Is it clear, students? We write this multiplication factor outside the box containing the particular, the respective atom. Okay, so in this case oxygen. So here we write the value 3 outside BaSO4 box. Okay, then what is the next step? Consider aluminium atom. So what is the number of aluminium atoms in the reactant side? It is Al2. So 2 atoms are present. In the product side it is Al. So one aluminium atom is present. So in order to make it equal, what we do? We multiply the product side with the value 2, right? So now the number of aluminum atoms in the reactant side and product side is how much? 2, right? Okay, so we are multiplying the product side with a value 2, right? So here the aluminium is in which box? In this box, right? AlCl3. So write the value 2 outside this AlCl3. So the equation becomes BaCl2 plus Al2SO4 thrice plus 2 times AlCl3 plus 3BaSO4. Is it clear, students? We write this multiplication factor 2 outside AlCl3. Okay. So what is the next step? Take the another element, barium. Okay. In initial, what is the barium? Initial means in the previous step, we found the equation to be BaCl2 plus Al2SO4 thrice gives 2AlCl3 plus 3BaSO4, right? So here the number of barium atoms in the reactant side is how much? It is 1, and in the product side it is 3Ba. So there are 3 barium atoms. So in order to make it equal, what you have to do? Multiply the reactant side 1 with the value 3, right? So here the value becomes what? 3 now, okay, in the reactant side, and in the product side it is 3 itself. So we are multiplying the reactant side with the value 3. So write this 3 in the 3 here, okay, outside the box of the reactant side BaCl2. Okay, so now the equation becomes how much? 3 BaCl2 plus Al2SO4 thrice gives 2 AlCl3 plus 3 BaSO4. Is it clear, students? Okay, so what is the next step? We have to check whether the all elements are having equal number of atoms in the reactant and product side, right? So first take the barium atom here. It is 3Ba, right? So the number of atoms is 3 in the reactant side, and in the product side it is also 3Ba. So it is equal, right? Then next consider the chlorine atom. See, it is 3Cl2. That means 3 into 2. So there is a total of 6 chlorine atoms in the reactant side, and in the product side it is 2Cl3. That is 2 into 3, 6 chlorine atoms in the product side. So see here also the number of chlorine atoms are equal, 6 each. Okay. Then consider another other element, aluminium. See here in the reactant side it is Al2. So there are 2 aluminium atoms in the reactant side, and in the product side it is 2Al. So again 2 atoms in the product side. So that is also equal. So the remaining element is sulfur. So sulfur, it is inside the box, it is 1, and so it is S3, right? So 1 into 3, that is there are 3 atoms, sulfur atoms in the reactant side, and in the product side it is 3S, right? So that is also 3 sulfur atoms in the product side. So what is the number of oxygen atoms in the reactant side? It is O4 thrice. So 4 into 3, that is 12 oxygen atoms in the reactant side, and in the product side it is 3 times O4. So 3 into 4, again it is 12. So see students, here you can see that the number of atoms of each element, of all elements in the reactant and product side are equal. So we can say this is a balanced chemical equation, right? So just write the equation once again, removing all the box. So we'll get the balanced chemical equation as 3 BaCl2 plus Al2SO4 thrice gives 2 AlCl3 plus 3 BaSO4. Is it clear, students? See, by practicing more questions, you will be thorough with it and you will be able to do it fast. Okay. So that's all about writing a balanced chemical equation. Now we'll discuss about the different types of chemical reactions. Okay. So there are basically 5 types of chemical reactions. One is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction. Today in this class, we will be discussing about combination reaction in detail. Okay. Now let's discuss what is a combination reaction. A combination reaction is a chemical reaction in which a single product is formed from 2 or more reactants. Okay. So what is a combination reaction? A chemical reaction in which 2 or more reactants combine or react to form a single product. Is it clear, students? So say suppose A and B are the 2 reactants. Okay. These 2 react together to form a single product C. So such type of reactions are known as combination reactions. Okay. So A and B, 2 products, there can be 2 or more products. Okay. They react to form a single product. Such chemical reactions are known as combination reaction. Okay, some examples for combination reaction is, see, quicklime, that is calcium oxide. Okay, but that when reacts with water gives calcium hydroxide, that is slaked lime. Okay, so calcium oxide reacts with water to give a single product, calcium oxide. Okay, heat is produced along with this chemical reaction. Okay, so the by reaction of these 2 products, a single product is formed. So such an chemical reaction is known as combination reaction. Okay. Another example is burning of coal. Coal is basically carbon, right? So carbon reacts with oxygen while burning to form carbon dioxide gas, right? So carbon dioxide, only a single product is formed. So this is a combination reaction. Then another is formation of water. Hydrogen and oxygen reacts to form water. Okay, so this is also an example for combination reaction. See, in the first example of combination reaction, that is when quicklime reacts with water, along with the product is slaked lime, that is calcium hydroxide, right? After this chemical reaction, heat is produced, right? So such reactions are called exothermic chemical reactions. So exothermic chemical reactions are those chemical reactions in which heat is released along with the formation of products. Okay, so what are exothermic reactions? Exothermic chemical reactions are those reactions in which heat is released along with formation of the products. Okay, so other example for exothermic reactions are burning of natural gas. Natural gas is what? Methane, CH4. You will study about methane and all in detail in this class 10th in the like you'll be studying about hydrocarbons, okay, carbon compounds, then you'll learn about it. So natural gas is methane. Methane reacts with oxygen to form carbon dioxide and water, and heat is also generated along with this products. Okay, so we can say that this is an exothermic chemical reaction. Another example is decomposition of vegetable matter into compost. Okay, then respiration. That is also an example for exothermic chemical reaction. See, glucose, that is C6H12O6, reacts with oxygen to form carbon dioxide, water, and energy. Energy is in the form of heat. Okay, so here the heat is produced along with the products. So this is also an exothermic chemical reaction. Is it clear, students? Okay. See, we studied that the quicklime, right? Quicklime reacts with water to form what? Slaked lime solution, that is CaO, calcium oxide, reacts with water to form calcium hydroxide solution. This slaked lime is used for whitewashing. Okay, and when this calcium hydroxide reacts with the carbon dioxide in the air, then what? Calcium carbonate is formed. CaCO3 is formed along with water. And this calcium carbonate causes the shining off on the surface of the walls. When the quicklime reacts with water, calcium hydroxide, that is slaked lime, is formed, and this calcium hydroxide reacts with carbon dioxide in the atmosphere to form calcium carbonate, which causes a shining effect on the surface of the wall. Is it clear, students? See, remember that quicklime is CaO and slaked lime is CaOH twice. Solution of slaked lime is used for whitewashing, and calcium carbonate causes a shining on the surface of the wall. So this question has been asked in your previous year questions. So that's all for today's class. Thank you, students. Please do like, share, and subscribe our channel and log on to our website inviewpoint.in to join our courses. Or you can contact us via email at info@inviewpoint.in. Thank you. Have a nice day.